Welcome to C4.12, Group 7, the halogens. So we're going to look at the elements in Group 7, and the collective name for those is the halogens. So our lesson objectives are to recall the physical and chemical properties of Group 7 elements, to predict properties from trends that we've been given, and to explain the reactions of these Group 7 elements. We're going to start with the physical and chemical properties of Group 7 elements. So starting with the physical properties, you need to know the appearance at room temperature. So as you can see in the table, fluorine is a pale yellow gas, chlorine is a pale green gas, bromine is an orangey brown liquid, and iodine is a shiny black crystalline solid. So we know from our work in C1 that most substances go from solid to liquid to gas as the temperature increases. Iodine is unusual in that it sublimes. So what that means is instead of melting, i.e. going from a solid to a liquid, it goes straight from a solid to a gas. And when iodine sublimes, it goes from being a shiny black crystalline solid to a purple vapour. We need to know about how we find the elements. So the elements are found as molecules because they're diatomic. So di means two, and atomic means to do with the atom. So what that means is that all the Group 7 elements exist as molecules which contain two atoms of the same element. So the formulas, remember your little two, your two needs to be little, and it needs to be lower down, so it needs to be subscript. So the formulas for the molecules are F2, Cl2, Br2, and I2. We need to know about the trends. So as we go down Group 7, the following trends occur. So the density increases, and this makes sense if we think about that as you go down Group 7, the size of the atoms are increasing. So in this case, of course, they're molecules, so the size of the molecules are increasing, and they're going to be heavier. So each of those atoms and molecules has got more mass, therefore the density is going to increase, assuming that the distance between the molecules is roughly the same. The melting and boiling points increase, and that's we don't need to know the explanation of that, but it's because as the molecule gets bigger, the forces between the molecules get bigger, so therefore it requires more energy to overcome them. So we also need to know about the chemical properties of Group 7 elements. So we already know that Group 7 elements have 7 electrons in the outer shell. When they react, they're going to gain 1 electron to gain a full outer shell. And that electron will normally come from a metal when we're talking about ionic compounds like we are on the next slide. Although, of course, Group 7 can form covalent compounds as well with other non-metals. So it can be from a non-metal. So the typical reaction that you need to know about is a Group 7 element reacting with metal. So in an exam, you're likely to be asked about it reacting with a Group 1 element. So, for example, sodium reacts with chlorine to give sodium chloride. The balance equation is on the slide there. And if we think back to our ionic compounds work, C2.2.4, we should know that when a halogen reacts with a metal, the ionic compound, we should know how to name that the element chlorine will turn into chloride because it's now a chloride ion, and that's going to have a charge of -1. So instead of being chlorine, it goes to chloride. So bromine would go to bromide, iodine would go to iodide, and fluorine would go to fluoride. We need to explain what's going on with these reactions. So Group 7 elements gain an electron, as we've already said. As we go down the group, the atom gets larger. So if it's larger, and it's trying to gain an electron, then it's going to have a weaker attraction between the positive nucleus of the halogen atom and the electron that it's trying to attract. So if it's further away and it's got a weaker attraction, it's therefore going to be more difficult to attract the electron, and therefore the larger atoms are going to be less reactive. So that means that the trend in reactivity going down Group 7 is that they become less reactive as you go down the group. The last thing we need to be able to do is predict properties from given trends. So, for example, you might be given a data table like this, where it's got the melting points and the boiling points and the density. We've already described the trend in those. So all we need to be able to do is to look at the gaps in between them and predict what we would expect. So for a melting point, for example, you can see the difference is roughly about 100 degrees, so you'd expect that to be somewhere greater than 200. And on the next slide, we can see what they actually are. Thank you, and see you for the next video.